It's 2 o'clock. Welcome everybody. Such a big crowd for our first program of the year, June. I'm Mark Hennessy. I'm Executive Director here, and so thanks all for making the trip up here. These programs are the result of a grant that we get from Visit Cook County and also from generous donors. So thank you. Many of you are members and give generously. So thank you for that. We've got a busy summer. Pretty much any day of the week you can come and show up and we'll have something going on. Tomorrow I'm actually giving a presentation on the wolf-moose dynamic on our porch. Tuesdays are kids' days. Thursdays we have a planetarium that will be starting up in July. Fridays Emma does our nature hike that has a theme each week, a different theme. And then Sundays during the summer we do our program. So lots going on, and our next program is coming up. I'm going to miss this one, but it's Teddy Roosevelt, the wilderness warrior. We actually have Teddy coming. This guy, it will be entertaining and quite fun, I think. Talking about the wilderness, and Teddy Roosevelt was really instrumental in starting the Forest Service and other things. So that should be good. And then you're all invited back for our birthday open house, which is on July 5th, Saturday, and from 11 to 4, but we'll have a program going at 1 o'clock that day. Birthday cake, and I believe it's carrot cake coming from Crosby Bakery in town. So that will be worth the trip alone. And then one more, all you nature people, I can see we've got a crowd of you today. This is going to be entertaining also. We have Sam Gaida coming talking about galls, burrows, and brooms. Oh my. So it's about those things that grow on trees. Very interesting. This guy is the expert of all, probably the world-renowned expert on these things. So that will be, looks like Sunday, July 6th. So, and then programs every week, so check out your schedule. I'm going to introduce David Coleman, who is our past president extraordinaire, to do our introduction today.
So Al is very modest, and he tried to capture his entire biographical sketch in about 22 words. And you've seen it. And I said, you know, we just have to do a little more than that. We need to do a little more than that. So he said, okay. I said, you can add the fact that I was born in Detroit. Yeah. Where I spent 40 years on the university faculty. Do you remember what hospital?
Grace?
Yeah. It's not there anymore, but
I don't know.
It's not, but I'm glad that you survived it. Anyway, he also did degree work at Colorado State University, and then the place up the street from Detroit, Michigan State. Not Michigan, huh? No? Okay, well that's okay too.
Spartans, I guess.
Yeah, it's all good. But I've gotten to know him over the last period of time, particularly starting out when the yarn shop opened and building all kinds of IKEA cabinets and everything else, and it's just been a delightful thing. And in other conversations, including running into each other in the library and figuring out where to transfer some valuable documents, we were able to work together and make that happen. But I would characterize him as a true scholar, a true artist, and highly successful in his professional business. Just an incredible person. And the title is up there, The Geology of Cook County, Minnesota, Oceans, Volcanoes, and Glaciers. Oh my. And it sounds like there's another one coming up that has the same title.
And I'm not giving that.
I know. So welcome. We've got a nice crowd here, and we're very happy and very pleased that you could be with us today.
Great.
So thank you.
Yeah. for the welcome, and thank you for the intro, and thanks to the Nature Center staff for setting this up, and I really appreciate it. This is fun for me. Nervous, but fun. And the trick is, all my life, all my career, I've given countless, hundreds of public meetings, business meetings, all kinds of travel meetings, etc. And I'm out of my comfort zone every single time. It's like Katharine Hepburn with stage fright before every event. 1 minute into it, I'll just be back to Al. But the beginning is that. So, you know, anytime you have a chance to speak or present or say something, it's always good to just, you know, the anxiety's there, but it can drop. It will drop. And for me, what I have to do is breathe out instead of breathe in. There's no more room to breathe in when I'm starting. So anyway, that aside, what I'd like to do here is talk about three basic concepts, or three big concepts. So the big picture geology of the region around us and in Cook County. And then secondly, zoom in to within that region, Cook County itself. And then lastly, after we've gone through all these slides, we'll have a chance, if you want to stick around and chat. I've got a number of rocks that are pictured in here, or you may or may not have seen, or if you have a rock and want to look at it together, we can do that. So that's kind of an afterglow. But first we'll start with slides and chatting. And we actually have a lot of time. This is a good chunk of time. There's actually plenty of room if somebody wants to raise their hand or speak up and say, wait, you know, could you say that again? Or say it in a different word or something like that, or you have a comment to add in, please do that. This is very, very casual, and time is our friend. So in a big picture sense, there's a couple of features in this region. And the region means, you know, well, we'll see it in a minute, North America. One is the Canadian Shield craton, and it's often referred, if you read about it, it's often referred to as the stable craton. And it's, you'll see, I mean, there's plenty of things that have happened to this so-called stable craton, volcanoes and earthquakes and asteroids and glaciers and anything but stable. And I'm not sure it's stable today, but it's quiet. And then the second thing in the region is the mid-continent rift. And rift is like big fault zone that traverses this area and our county. So the Canadian Shield, in this map, you can see there's us in Minnesota, and the gray area are outcrops or rock types of this so-called Canadian Shield. And if you think of it as a high spot in North America, and everywhere from there, if you imagine, kind of slopes downward, with the exception of the Rocky Mountains and things like that. It's sort of like a dome, and this is the core of the dome that's being eroded off, and flanking it on all sides like a layer cake are more and more younger and younger, more recent layers of lavas and sandstones and limestones and shales. But the core, which is exposed in a lot of Canada and down into our neck of the woods in the US, is a lot of very hard, resistant to erosion rocks like granite and things like that, and basalt. So anyway, that's the Canadian Shield. And if we look at another big feature, the so-called mid-continent rift, you can see in the little explanation down here this dark gray and the light gray. And the dark gray is basalts and gabbros. And those are the kinds of rocks you see throughout most of the county, particularly along the North Shore, particularly in the Sawtooth Range. And the light gray are, they're not gray sandstone, but they represent sandstone that's, or sand that filled in a trough that had this basalt and gabbro molten rock in it at one time. So anyway, the idea with a rift is, if you've heard of the East Africa rift, goes through many countries. It's a splitting apart, a pulling apart of the African continent, which has a craton core to it. And it's active, it's still splitting. This is a so-called failed rift. It was a rift in the middle of the continent about 1 billion years ago, based on the age of the rocks from chemistry and stuff like that. And it never kept opening and making 2 or 3 continents out of one. It stopped. And the lavas, the basalt lavas and the gabbro molten magma froze in place and sort of glued the rupture in place. But it's a really, really unique feature for a lot of reasons. For one is it's the dominant rock type that's exposed in our area. It's just igneous basalt and gabbro molten rock. It was volcanoes, not cones. Kind of like on the base of the seafloor now in the Atlantic Ocean, for example, where there's seafloor spreading. There's rifting going on and very, very deep faults or rifts or cracks that go down and they tap this composition of molten rock from deep in the earth in the mantle. And that comes up into the base of the ocean and it cools quickly because it boils. I mean, not it boils, the water boils around it, cools it off, and it just freezes. But the ground keeps pulling apart in the ocean, and this stuff just keeps coming up. And the whole ocean floor is just, from continent to continent, this kind of basalt and gabbro. Here, it happened for a long time, and then it stopped. It's also very metal mineral bearing. So it is this kind of rock, the black and the gray, where you find copper, like on Isle Royale and over on the Keweenaw Peninsula, Michigan. It's where you find copper and nickel a little, right about there, a little further inland over on the Iron Range. Those minerals come from this rock itself. They crystallize right from the molten rock. And thinking again that the craton is sort of a dome, and it's the core base, oldest rock in that dome, and everything else is layered on top of it and cracked apart and infilled with this lava. As you go away from our county to, let's say, you head to the cities, you're traveling over the rift and you're traveling over the same rock types, except you get to the cities and there's sandstone in the Mississippi River Valley and the waterfalls, and there's sandstone at Minnehaha Falls, and there's sandstone in St. Paul on the river there. That's younger sediment that's been deposited on top of these rift rocks. So this map is talking about a feature that's exposed at the surface in some places and deep under other rocks, and it extends all the way to Kansas and around through the UP and Michigan and Ohio. And everywhere along there, if that's exposed, or if you sink a mine shaft or something and go down, like in in this area, there's a lot of mineralization in that rock type, and it's only known because people have gone down that deep, past the sandstones and limestones and into it. So anyway, it's a bizarre thing, and but it's an important piece of our neck of the woods. There's a couple of seats up here if you want. Okay. I feel like I'm taking up many of them. So here's a geology map, kind of an artist's rendition, if you will. These colors each represent a different kind of rock. These aren't the colors the rock would look like, but they're just, each color represents a particular type of rock. So where we are, I wish I had a physical long pointer, but I do not. See if I can. So here's our county, or the county we're in, let's say. We don't necessarily own it. We're sitting right up here where this pink is, and that pink correlates to a granite rock. And it's only a small portion of the area of this county. The other is a blue, which is said to be meta-sedimentary rocks. And then whatever you call these two colors, those are the basalts and gabbros of that mid-continent rift that cuts through the region. And then there's many other colors and lines and so forth that represent other kinds of rocks. This represents if you could peel off the glacial sand and gravel and soil and trees and lakes and rivers, this is thought to be what the rock, the top of the bedrock looks like, but not necessarily one layer down or 2 layers all the way to the core of the earth. It's just the top of the bedrock. And so as you go south, you start to see these other rocks that are laying on top of this. And then this little map, if you can see that well enough, it's kind of interesting. Yellow represents, if you're standing on the ground surface, there's about no outcrop. You're standing on soil, you're standing in a bog or a wetland, or you're standing in asphalt or concrete if you're in the cities, but there's virtually no bedrock sticking out. And then as you get up to our neck of the woods, there is. There's more sticking out, and yet we can't see rock everywhere here. It's covered by trees and soil and lakes and wetlands and so forth. So the point is, this is an artist's rendition or a geologist's rendition of what could be if you connect the dots. And it might also not quite be that way. It's science or whatever, it's art. So anyway, that's the neck of the woods. So there's, if we zoom in a little more to, not really Cook County, but northeast Minnesota, I think of it as 2 major rock types in the neighborhood. So here we are at the end of the Gunflint Trail, close to it. We're in this granite and this bright green, which is greenstone, slate, meta graywacke. And then the pink is granite. They're about the same age. These are grouped by ages. And then the rest of the county, up here, these colors, I think are these 2. Duluth complex, that's the gabbro intrusive molten rock. And then North Shore volcanic group, which is basalt lava that came to the surface. And when you hear basalt and gabbro, they're both molten, they come from molten rock under the earth or in the earth. And if the molten lava comes all the way to the surface and flows out into what we would call lava, a flow on the surface, it'll cool rather quickly and it'll be very, almost not crystalline. It'll just look like dark black, gray, super fine grained thick rock. Anyway, that is called basalt. The exact same molten rock coming up, but if it doesn't make it to the surface as lava, but stays underground as kind of a vein, and it crystallizes there, it crystallizes bigger than the lavas because it's insulated by the rock on either side of it. So it takes maybe thousands of years, I don't know, to cool and crystallize. And so it's the exact same minerals, the exact same chemistry, but coarser crystals because it had a longer time to grow. That's called gabbro. And sometimes you'll hear those words in different signs or whatever, and they're the same rock, but just how they form is a little different. So, let's zoom in. Why don't we touch on basically 3 things. So one is, I'll call it ocean floor rocks. That's the rock types that are in this neck of the woods, the granite and I think it's called greenstones. And then secondly, we'll talk about the other bulk of the rocks in the neighborhood, which are the gabbro and the basalt, the lavas and the intrusive rocks. And then third, the effects of glaciers, which aren't, I mean, that's not a third rock type, that's a bulldozer of ice that came through and sculpted off the tops of the other 2. So those are from my point of view, there's 3 things about the county that might be interesting to focus on. There's some seats up here if you'd like. Okay. Okay. Yeah, come on up.
There's lots of
Take your time. Okay. So, first of all, the area of ocean rocks. The types of rocks are generally called greenstone and granite. And the granite is pink. You can see it right outside the window here at Pond, or at the entrance on the road. The other rocks are just a bundle of things that are generally a greenish tint. And that includes the salt lavas that are very, very old, older than the rift rocks that were formed in the region. Chert, sandstone, slate, iron oxides, those are all ocean deposited types of rocks. And they're tinted green by later alteration of certain minerals in them that make them turn green. So geologists, anybody that's looking at rocks might just say, well, that's a green rock, and you're right. Or you could spend a career trying to dissect them and figure out what kind of rock turned green. And I just call them greenstone. So back to this northeast Minnesota map. So we're talking about the ocean floor rocks on this are called older rocks. So they're shown in gray. In this map, nobody seems to know what's over the border. But there's not a box for white, so I don't know what it is. But it's this zone here that we're talking about, and they're ocean floor mineral deposits that have, obviously we don't have an ocean anymore, so we'll talk about that later. So they've sort of been exposed. The basalt pillow lavas are a really unique form of basalt or form of lava. Not chemically, but physically. And around the world, if you see lava coming up in the mid-ocean ridge or the mid-Pacific ridge or wherever underwater, blobs of it come up and they form like a little balloon that quickly quenches and just sits there, and another one squirts out from the crack in the base of the ocean, and it just sits next to it and next to it and next to it. And you get a whole bunch of these. These are referred to as pillows, and it's a textural thing. It does not happen when molten rock comes to the surface and flows for miles and miles and miles, like the Columbia River basalts in Washington and Oregon, or like the North Shore volcanic group, where you see the Sawtooth Range as you're looking down from maybe Grand Marais, looking down the shore, and you see layer after layer. Those were flows that came out into the surface, and they do not have this particular texture, pattern. Most of the rock is actually a mixture of chert and iron formation. The chert, the gunflint chert, is the name of a big group of assemblage of rock types, but it's all over this area. And it consists of chert, which is quartz, and it's thought to have been precipitated by in the bottom of the ocean, deep, and interbedded with shale, which was real fine, gritty muck or mud or something that settled on the ocean floor, long, skinny layers. And the chert it's not clear how it ever formed, but there's a layer of chert, and then a layer of shale, and a layer of chert, and then a layer of iron oxide, and a layer of chert, and then iron oxide, and it just goes on and on and on. And that whole package, we've got some examples up here, that whole package is referred to as the gunflint chert. Magnetic, and then within that chert there are some fossils, which up until, I don't know, maybe 10 years ago or something, these fossil algae were thought to be the oldest life forms found anywhere on Earth. And now there's a few found in rock types just lower than that. And
with algae in them?
Not live algae, but
yeah,
replaced by chert or replaced by quartz, but you can see the textures. So I have a couple slides actually coming up of that. Magnetic rock is part of it. The Paulson mine is part of this package of rocks. So here's gunflint chert. You can see it's gray, nondescript, but it is layered. And it's heavy as all get out. And you can take a magnet to certain layers in it, and it'll stick. and other layers that won't. And then there'll be another magnetic layer that goes on and on and on. That's the chert. Here's an example of some of the algae fossils in the chert. And they're just weird looking little, I don't want to say growths, but whatever, in them. And these are known worldwide. This is on the hike up to Magnetic Rock. And you can see this algae growing in the pond. And I thought it looked a lot like the next step you go is on the chert, the ancient chert. And it has some of these similar funny swirls. Yeah. And if you look at those with a microscope, you can actually see, maybe not the cell of algae, or whatever, but you can start to see the patterns they make as they form and build up. And that's very rare. This was for many years thought to be the oldest life form anywhere on Earth. And it also correlates to algae give off oxygen. I don't know what they consume, CO2, I'm not sure, but they give off oxygen. All the rock types on Earth above this kind of chert with the fossils in it start to have rust or iron oxide in them. And depending on your point of view, you start to see animals and plants giving off more oxygen, and animals starting to form and get more and more complex. And pretty soon you have petrified trees, you have fossil trees and fossil this and that and the other. But the algae is the first, and it started to oxygenate, if that's the word, the atmosphere. The Paulson mine along the Centennial Trail was the first attempt at mining iron in the layers of the chert, or in cracks and weathering of that chert, and it turned out to not have enough iron to be economic, at least back then, and probably not today either. But it's the exact same mineral deposits in layers and chert as we have over in the Iron Range, or the Cuyuna Range in Minnesota, and those have an enormous amount of iron, mineable iron. And I do want to say, I grew up in mining. I've worked in underground mines, I've worked in surface mines, and I cannot emphasize enough to not try and go in something like the old workings of the Paulson mine. It's fenced, but I could hop over the fence. The dogs could run over the fence, under the fence. And the only reason I bring that up is it's just like caves underground. We don't know how stable the roof or the top of that tunnel or that shaft is, and they do fall and they do collapse. We don't know the quality of the air inside. There may have been decaying wood, and that consumes oxygen, and that leaves no oxygen in an otherwise nice looking hole in the ground. So as a safety share, I would just say, please don't ever go into something underground like this. Shifting gears, this is Middle Falls up on the Pigeon River, past High Falls, keep walking, and this is Brother Rick and me. I thought I found copper in a vein it was white calcite, kind of like this. This is from the Mount Josephine, kind of one of the road cuts on Highway 61. But there's a little one right there, and I thought it was copper, so we were looking and looking, and I'm not sure still. Needed a microscope or something, but either way. Then we looked up and we saw the river. Thank you. Safety share, daughter Dorothy. In fact, me on the right, I'm pretty close. I think my foot's in the water. So it's so funny. We go out into nature with a purpose or rambling or whatever, and we see some things and we don't see others. You know, you go looking for birds, you don't see the rocks. You go looking for rocks, you don't see the river. But at least we get out, right? So another really cool and rare thing, I think, is this Sudbury asteroid impact layer. And this is, if you know of Sudbury, Ontario, it's about 500 miles to the east of here. It's one of the world's largest series of nickel deposits that are being mined. And it's roughly an oval-shaped area with all this mineral inside it. And what's really neat is it's thought to be a very large asteroid. Maybe a meteorite, maybe a comet, not sure what, but it hit the ground. And in doing so, there's this regional hypersonic, faster than the speed of sound, blast that happened 500 miles away and left a layer of breccia, which means broken rock, broken chert, broken iron formation, broken granite, you name it, and glass beads and ash. Ash not like from a fireplace, but ash from like a volcano that's little shards of glass and rounded melted beads of glass in a little layer on the top of the iron formation. And there's a piece of it, we'll look at it later, but bizarre thing. And there are outcrops along beyond the magnetic trail and other places which I would love to go see. And as I understand, it wasn't really known, other than the fireplace, that the rock, the fireplace that the Gunflint Lodge has, this wasn't known where it came from for a long time, or how it might have ever formed. But people have found occurrences of it here, and in Michigan, and in Ontario, and more of it as you get to this giant nickel deposit that made no sense as to why it formed. And it's thought to be a little layer of blasted material. Here's a schematic somebody drew of what they think. This is a cross-section, two cross-sections of the ground. One is as the meteor, the black thing, is hitting, or asteroid. They think it vaporized the rock that was there, turned it to gas. They think it melted more rock peripheral to that. And then after, and then it made this crunchy layer for 500 miles that we know of in one direction, so maybe in all directions, I don't know. And then it left a lot of melted rock, either from the asteroid or from the melted ground, or both. But it's super high nickel, and it makes no sense why it's even there. But that's another really odd. We have some of the oldest fossils of life forms on Earth here in this county, and we have an occurrence of this bizarre asteroid. The debris rock is made up of broken pieces and other rock and glass. Here's some pictures from one of the books I brought here today. There's another piece of it over on the table over there, and it's like a puzzle, a rock that's all broken up, and you couldn't put it back together again, I don't think, to find how to piece everything. They're blasted apart, not just cracked, they're blown apart, and the matrix in between the broken rock is this melted, glassy, whatever you want to call it, rock. It's just bizarre. Yes?
Is the nickel from the meteorite itself?
Yeah, that's a debate going on right now. Like some people say it's from that. Other people say no, I think the dent went down so deep, it went down deeper than the crust of the Earth and into the molten mantle where there starts to be more and more nickel. And the core of the Earth, if it affected that, I don't know, that's way down, but that's molten nickel and molten iron. Though no one's ever drilled down and sampled it, it would melt your drill rig. But through inferences, it's that. So the answer is nobody knows.
Oh my God.
But whatever it is, it's sure left its mark. Here's a picture from the display over here, the broken up pieces of the Gunflint Church. And filled in with, I don't know, but looks like sand or iron oxide or something. But it's unlike any other rock in the county and the region. Yeah?
How do you guys know that it hit here? We were here, that this was the starting point of the 500 miles.
So the starting point was actually 500 miles away.
Oh.
In a town or area called Sudbury, Ontario. Okay. And there's a whole bunch of nickel mineral deposits there, and a thick layer of this stuff there, and then thinner layers found in Michigan, here and there, and then just, I don't know how deep it is. It's not very thick here. So it's the idea, the inference is it probably hit there, 500 miles away, and it raced at supersonic speeds. Not it, but the blast. And it would have wiped out, if the cherts and the iron was being deposited in slate, which is muck from the bottom of the ocean. If all of that formation was still under the ocean, it would have vaporized the ocean and picked up pieces of the ocean floor, busted it up, and blasted them sideways. So, and was anybody here? No. You know, is there good outcrops exposed in Minnesota and Wisconsin and Michigan? No. But there's enough that you can connect the dots, and that's the latest theory or thought for now. But I guarantee you in geology, or anybody's cool idea is going to have just as much bearing. In the next 10 years or 20 years, there'll be a variation on the theme of the story. Excuse me. So, excuse me, overlying the Gunflint Chert Formation and then that breccia formation from the blast is this stuff. And this is a road cut on Highway 61 up near, it's in the Grand Portage Reservation near Mount Josephine. And it has a lot of slate or shaly material. It's just super finely layered. It's very different than the harder, thicker layers of chert. This type of rock, slate, again, forms in an ocean. And so that must have been an ocean again after the meteor or whatever asteroid hit. And in the bottom of the ocean, just sediments just settled down and they formed this slate. And if you go up to, I can't remember the name of the falls, but you go past the border on 61 and go a little further and you turn left and there's the big waterfall with a bridge over it.
The High Falls, Pigeon River Falls.
Is it Pigeon River?
Oh, they call it the High Falls.
Oh, no, further.
Oh, beyond that.
Say it again, Chik-Wauk?
Kakabeka.
Okay, yeah. If you go on the walking bridge and you look down at the waterfalls, there is the most spectacular pieces of this slate, and you're looking down on it, and they're like super sharp angles. It's like it's cracked in these they look like saw marks. And they're big plates. You could make not that you have to make something out of rocks all the time, but you could make a pool table, I thought. You could go to the side and chisel, and it would just peel up, and then you cut it into a rectangle. I think you need holes, too. But that's called the Roe Formation, and that's the last of the rock types in this huge package of older rocks, as it's called on that one map, and things that predate the basalt and gabbro molten rocks that came up through the rift, the big regional crack. Oh, except for the granite. So then there is some granite, pink granite here and there that intruded through the slate and the chert and so forth, and that is all over here. Literally, this is right outside the window, just across at the pond. And that's just another rock type in the package that's loosely called greenstones. And you can just go on and on and on, or you can say, oh, it's greenstones, it's older, now let's look at something else. That's geology. So let's move on to bucket number 2, which is about the volcanic rocks and in that rift. And all of these come up in the zone of the mid-continent rift, which are deep, 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 really deep, hundreds, thousands of feet deep vertical cracks into the earth. These rock types also are the ones that have or have formed in them Lake Superior agates and Thompsonite, which can be really fun to find. So back to the map here of the northeast part of the area. Here's the dark gray older rocks. That's all we know about them. That's the greenstones and the granites and the cherts and all that. And now we're going to look at the Duluth complex and the North Shore volcanic group, as it's called here. So lavas and intrusive rocks of the exact same composition, but some flowed out on the surface of the earth and cooled quickly as a lava, and some stayed underground and cooled slowly, and they're coarser grained. And these rocks are really hard from a grinding perspective. So they remember the rift cutting through the area. Here's some basalt you can see at, this is at the harbor in Grand Marais, and these are basalts here. And they kind of taper down into the lake, and then this is kind of a misty, foggy day or whatever, but you see the slope of the Sawtooth range that you drive at the base of all the way down to Duluth. Those are layers of lava, one after another, stacked up like a cake and dipping into the lake. Some of them, this is from Oregon, but some of them, even at something like Artist Point, and many other places you might go around the lavas, if you look down at your feet, you often see this hexagon, or what's a 5, pentagon. It cracks vertically into these pentagon or hexagon shaped columns. Not quite as sharp and perfect as this, but close in a lot of places. And that's a weird cooling, crystallizing feature of this basalt. But it's just a neat texture, I think. Makes for good garden rock, too. Here's a road cut along Highway 61 at Cut Face Creek. And it has this very dense, very solid, blackish, dark gray basalt that was deposited on top of some sandstone. And it's really, really interesting to walk into Cut Face Creek. This is a highway road cut. And speaking of safety, I've done this so many times. Go to the base of the road cut, around the big rocks that are sitting on the ground, and start chipping away, going, ooh, what's this rock and what's that rock? And you talk about dangerous. One rock, this could take out Al, right? Coming from up high. But anyway, it is safer, I think, to go into a creek like Cut Face Creek around this corner. And as you go uphill in the creek, because creeks flow downhill here, water flows downhill here, I guess, too. As you go up creek, you're going through layers of sandstone and lava and sandstone and lava and sandstone and lava. And it keeps changing only because you're traversing up slowly through many multiple layers of these things. And this is friend Chuck who found a fault. So it's Chuck's fault, right? And this is a really good example of what a fault looks like, really almost anywhere in the world. It's a miniature example, or maybe a tiny piece of the whole wide rift zone here. But it's a kind of steep or vertical, broken up zone. And I don't know if you can see it real well in the photo, but you see how blocky the rock is on either side? It's a lava, it's a basalt. And as you get closer to this, you see these vertical lines, you see more of them, and they're closer space, and then they're all kind of ground up, and this looks like dirt, and then they're a little wider space, and a little wider space, and a little wider space, back to blocks. A fault is usually never one crack. Like the San Andreas is not a crack in California. It's a zone of cracks. And if they've moved in some way and ground up the rock in between, that's how you get earthquakes. You don't get an earthquake usually from one crack, you get it from movement along a zone of cracks. So this fault represents something, but in general it represents a lot of pressure and a lot of grinding and breaking of the rock on either side, and it would have been one heck of an earthquake that day. And there are many, many, many faults in this region. They're not active today.
Where is that located?
This is in Cut Face Creek. If you go to
Upstream?
Upstream, yeah. Yeah, so anyway, that's what a fault looks like, Chuck's fault. And then the gabbro, that very coarser crystalline igneous rock that came up in the rift, forms the knobs of a lot of hills in the 2/3 of the county from the Lake Superior shore inland, until you get to this part of the county where we have the older rocks and they're granite, if they're going to be a knob, or they're the hard chert. Well, in the rest of the county it would be gabbro, and with softer rock in between, which is apparently weathered away from the hard, intrusive, molten stuff that crystallized right there. And this is Barbara looking around on one of the knobs. We've all done something like this before. They make for great vantage points, and not much grows on them. Then within these rocks, within the basalt and within the gabbro, You can find Lake Superior agates right in the hard rock itself, or somewhere else where it's come out of that. But an agate is basically fine-grained, finely laminated or layered quartz, usually in an air bubble that was in the lava or in the gabbro molten rock. It's a natural gas bubble, and somehow fluid water got in there, probably a hot springs like Yellowstone, just percolating water through every little crack in the area. And if one of those cracks hit one of those big bubble areas, it could flow in there and it would cool and crystallize into these rings. It's a really odd phenomenon. And the Lake Superior agates are unique to this whole rift area. They don't form in Lake Superior, and they aren't unique to Lake Superior, but the whole Lake Superior area. And if we could go down underneath the cities or wherever else this rift rock is at depth, we'd probably find Lake Superior agates still embedded in the igneous rock. If you look up a little closer at these lava flows, like you see along road cuts or river cuts along the North Shore, for example, another phenomenon, you see all these little white specks, and then you see these little white, I don't know what they are, they look like worms or something. Those are quartz filling in, white quartz filling in what were open gas bubbles. And a pattern you can see with each lava flow, and each lava flow might be 10 feet thick or it might be 100 feet thick. They're just, nature spit out a certain amount at each time it did, and they were different thicknesses. But one unique thing about the gas bubbles is at the top of a flow, the upper part has circular gas bubbles. And the bottom of a flow has these worm-like, not animal-like, but tubular gas bubbles. And then the middle of the flow has no bubbles. And so here we're looking at the top of one flow, the bottom of another, and the middle of another, and somewhere up here would be the top of it. And texturally you can see the gas bubbles tell you roughly where you are in the sequence of any given lava flow, which is just curious. Then some of them aren't just white quartz or still an open gas bubble with nothing in it, but they have these reddish, orangish, whitish, grayish, banded quartz fillings inside them. And they're kind of like an onion, except they precipitate on the walls inside the gas bubble first, and then on top of that, or next to that, and it grows interior. So the youngest, the last stuff to form is the little dot in the middle. So that's the opposite of an onion, I think. Right? Here's the partner Trudy looking for agates, and our dog Gracie's wondering, like, what are we doing here? The rock hounds, you know. But you can find them in rivers, of course. It's a lot easier on a beach where you have 80 billion pieces of rock already ground down to nothing. And you can occasionally find an agate that's weathered out of the rock from the actions of the waves. It wore away the salt or the gabbro around them. And every once in a while you see, you find an agate or something else, right? And to me, I love looking for these. It's just another reason to go outside. And invariably, if you get looking for rocks, you can say I'm going to look for pretty whatever agates or something, and you don't see them. And the next person along goes, oh, here's one, here's one. Or you're looking and all you see are frogs, or all you see are gray rocks. Your head, your brain, your eyes, you tune in. Our whole being looks and sees different things on the exact same place. And every hour is different, or every day is different. And I like that. It's, to me, very needle in a haystack, but very relaxing to look for things. Here's sister-in-law Ann, who found her first agate. Look at the size of that, you know? And that, just pure joy, right? It's unbelievable. And here's a couple more. And so it's an agate doesn't mean the color. All the agates are different colors, but they are just crazy fine banded. Just white, milky gray, red, brown. I don't think we could even make something that finely made that nature has made. And I'm not even sure I understand how they're formed, but there is gas bubbles in the lava.
So that's how you know it's an agate, just because it's got all the layers?
Agate means banded.
Okay.
Yep. And if it wasn't banded, this came from Costco in the cities. In their, yeah, in the parking lot, in their, not in the parking lot technically, but in the gravel, you know, their landscaping rock, right? This is quartz, it's chert, it's mostly gray and has a little bit of iron staining in it, a little reddish, but no banding. So I wouldn't call it an agate, I would call it chert. It's a pattern or textural difference that the name goes to. And like any language, the words don't mean anything. I have to correlate them to a look of something and then remember that. And there's another really nice one. Dorothy, I think that's your hand right there, right? And it's also fun to, if you ever get a chance to saw open a rock with a diamond embedded saw blade. You can saw open the rock, and sometimes you look at a rock and you say, well, there's nothing in it. But it turns out that's the outermost part of the onion skin layers, and you cut it open and oh my, it's actually banded, or it's got all crystals in it, or it looks totally different than you see it on the surface. And here's Dr. Dorothy, who's made herself a ring. Oh, she's even wearing it. Yeah, so maybe polished the lake spear agate and then made a ring out of silver, and that's fun to do with rocks. So now we'll move on to Thompsonite as our, it's another very unique, kind of like agates are unique to this area, well Thompsonite is unique too, globally. And it is a form of what's called zeolite minerals. And zeolites are these, I don't know how you describe them, but little fibrous crystals, natural mineral crystals. And I don't fully understand it, but they have a crazy amount of internal porosity. So like a sponge is filled with porous open spaces and can soak up water and so forth. Zeolite minerals are used to clean up chemical spills. They're used in wastewater treatment plants in big tanks. They grind up, they find and mine the zeolites, put the powder in the tank, and pour water through it, and it cleans up contaminants in the water or silt or whatever. But it's this bizarre amount of water. And another way you can say it, if you ever find zeolite mineral, a rock that has the Thompsonite in it, and you want to cook it, if you could cook it and have it in a little glass thing, like a beaker or something like that, you'd see all this water that comes out of it that makes no sense. Like, how can it hold that much? So it's a weird mineral, but it's also very rare globally. And just like agates, which are quartz, they formed in these same kinds of bubbles and cracks, which once they're filled in with minerals are called veins. And you can find them in the exact same places that you'd find agates a lot of times. Or at the Thompsonite Beach Inn, I guess. And here's Trudy again with her big find of a Thompsonite on a pebble beach that had, we couldn't count them all, but I don't know how many pebbles are out there. There's a lot. And here's this piece of Thompsonite. And it's also a soft mineral. It actually won't last long in a turbid, wave, gravel, grinding environment. This stuff will grind away, versus the harder quartz agate things will not. They'll just keep pummeling around, but they won't grind away. Everything else grinds away around them, and so do zeolites. So it's even harder to find them on the beach. You actually need to go, it's better luck to go look in solid rock that you find somewhere and look for gas bubbles and see if it's agate or Thompsonite. And then the Thompsonite, here's some of it as a gas bubble filled in the rock. Here's the one Trudy found that had popped out or ground out, and she found it that day. And then here's polishing of it. It's a dome-shaped thing on its side to make into jewelry. There it is again. So the last bucket of topics is the effects of glaciers on these two previous types of rocks in the region. And again, the glaciers, if you've ever seen one, some of them are in mountains and valleys, and others are on whole flat, huge areas like Greenland, and used to be in North America, but they can literally be a mile or two thick, a mile or two high of ice wall, and coming at you, and it would bulldoze away any trees if they were there, or any wetlands, or any water, lakes, everything gets bulldozed away, as does a lot of the rock in the bedrock. And the pressure, the weight of 2 miles thick of ice on top of solid rock tends to fracture. Not very deep into the earth, and no magma comes up from down in the earth, but just the superficial rock 10, 15, 20 feet down gets crushed and then bulldozed by the ice behind it, and it ends up south or southeast, southwest, whichever way this ice was flowing, of where the rock came from. And then it also created the Great Lakes. And initially it created the water on the glaciers melting, filling in those depressed areas that were carved out by the glaciers. So again, there's no rock type that's about glaciers. It's what the glaciers did to these two zones of rock that we've talked about. And another artist rendition of what glaciers can do is, if you look at this, this would be like the surface of the land, lakes that are white, and then little ridges in between, and a cross section looking down into the earth, the different cherts and shales and iron oxide and so forth. The glaciers in the area, including this part of the county, they could grind down deeper in the softer rocks like shale, and the gunflint chert layers were really hard and resistant, and so the ice just kind of skidded over it, smoothed it and polished it, but didn't dig it down too much. And the reason we have lakes, and a lot of them throughout the region anyway are kind of east-west oriented, or they have a long linear shape to them, is thought to be the layering of the rock underneath. Hard on one side of the ridges on either side of the lake, and very soft in the bottom of the lake. But I don't think I've ever seen the rock in the bottom of one of the lakes. And I don't think we've drilled a well or found any way to sample the rocks under the lake. So this is a theory, this is an idea. But it makes sense in a lot of ways. So intuitive, I guess. And yeah, here's a classic lake in the region that's long and skinny and goes on forever. And if you hop out and hike to the tops of these ridges, or the edges of these ridges, you see the harder rocks that we've been talking about, the granites or the diabase or the gabbro, and you don't see shale, or you don't see finer grained, softer rocks. But you do see those if you drill or whatever into the earth. And as far as the Great Lakes go, this is another artist rendition from one of the books I brought here, and this is a cross section. So, you know, here's the top of the land, and this is down deep. These are in meters, so ×3, like yards. And you can see in relative terms, not the actual dimensions or the steepness of the walls of the lake, but in relative terms, Lake Superior is by far the deepest, and then, you know, it drains to this and this and this, and then it works its way out the Gulf of St. Lawrence into the ocean. And look at this line here, the sea level line. I don't think I ever appreciated it until like a year ago. So Lake Superior is actually deeper than the ocean. But the ocean is not ocean water, it's not salty. The ocean can't come in up the St. Lawrence and cascade up and over these naturally, you know, higher and higher lakes and get in here, but it's way deeper than sea level. I'm just curious. So it's thought anyway that the glaciers, that each lake represents an area of very soft rocks bounded by harder basalts and gabbros and things like that, and that the glaciers bulldozed their way down deep and scooped up everything and just deposited in southern Minnesota or Iowa or wherever. And then when they melted, the glacial water just filled in the Big Depression. But these would be like crazy deep, and canyons and things like that. Here's back over on Lake Superior and near Grand Marais. This is one of the lava flows that it no longer has this shape. It doesn't have the shape of these linear ones up here on the ridgeline, but it looks like a whale or something. But you go under and you can still see grooves that I think are from glaciers and rocks in the glaciers just pushing down and grinding their way on the outcrop, and it just sculpted it. A lot of grinding motion. And the glacier sculpted the tops of the knobs where there's the gabbro or the granite in this part of the county. And they ground away everything in between to make essentially valleys and lakes and rivers and wetlands and things. This is the granite, very sculpted, I think, by glaciers. And it's right out at the entrance to Chik-Wauk here, right where you turn onto the Gunflint Road. And then I guess, yeah, one of the last things we'll just talk about with glaciers here is going up the Magnetic Rock Trail. And this is our friends Chuck and Sylvia, the first time they've ever been there. And here's the magnetic rock. And it's a layered chert and iron mineral rock that looks to me to be exactly the same rock that you're walking on everywhere, but it's just peeled up and standing up balancing for some weird reason. And since nobody took a crane up there, or you know, kind of thinking it's probably from glaciers somehow peeling up the bedrock, and then they stopped moving, the glaciers stopped moving, probably stopped snowing in Canada, stopped making ice, stopped making heavy ice that pushed this ice further and further, and the conveyor belt just stopped. And the ice melted around it, and it left boulders sitting here and there on top of the chert, and then it left something like this, just peeled up. But this is fun too, because you can see the magnetic, you can take a magnet to it, like a refrigerator magnet or whatever you want, and a compass will always point to this thing, no matter where you're going around it. So it's great, it's easy to get lost. So that's that. And then if you think about, you know, is there still geology active? I mean, we've talked about oceans with sediment and lava and chert being deposited and granite and the big rift crack and basalt, and that would have been lavas or volcanoes. Then there were glaciers, you know, a mile or two thick bulldozing. None of that's happening today. But I don't think it's over. I think it's just we're in kind of a lull. What we have is a lot of water running around in different seasons and eroding valleys deeper, or you know, river valleys deeper. The effects of ice freezing and thawing on bedrock up in the hills or even on the shoreline pops bedrock apart and makes more smaller rocks, and the waves grind them up. But this is pretty tame geology to what the actual rock types that are here suggest from the past. So that's that. And I think we still have a couple minutes maybe for a couple questions, and then why don't we just break, and if you want to stay and chat or look at some of the rocks, we can do that for a bit. So, any thoughts, questions? Yes?
I have a question about, I have a friend who has a house in southern Minnesota, and he set up this fantastic dinner out al fresco, and it was like 9 or 10 getting dark, and we realized the mosquitoes. We were so surprised by that. We surmised it's because of it's the driftless area with lots of glacier carving out and lack of standing water. Is that true? Mm-hmm. I mean, why?
Was it winter?
It's in the drift. It was in July, and you know the cities are here when the cycle is down. We go in, right?
It could very well be the lack of gently sloped topography that now holds water and wetlands and all kinds of insects. If you're in an area that drains more, you know, it's drier, and that I would think would have less bugs or less mosquitoes and so forth. Is it in the driftless area?
It is in the driftless. When I asked, he said, well, it's because it's the driftless. But I said, what does that mean? And he didn't really go further with it. Why?
So it's apparently driftless is a part of southeast Minnesota and southwest Wisconsin and northeast Iowa that the glaciers didn't carve, but they went completely around it. And it's not hard rock, it's limestone and stuff. And so it's what the topography looked like before the glaciers bulldozed everything around that zone. I don't know, that's a odd one. I don't know. But it wouldn't have as much standing water as a bulldozed region that we have. That there's just ponded water all over the place. Or even if it's all interconnected, all these wetlands and lakes, if they're interconnected and flow to the Pigeon River or the whatever, the rate of flow is so slow, it's pretty much stagnant, you know, and lots of insects. I don't know if that helps. Yeah?
Down in Duluth, there's several layers of Lake Superior beaches,
Yeah.
suspended beaches.
Yeah.
Why don't we have those up
This part of the county or on the North Shore?
here on the North Shore?
Yeah, I think we do. I'm actually, it's one of these things, it's like a simple question, but I don't know how to answer it, how to figure it out. But we live in Grand Marais, and one of, you know how all the streets, if you walk from Buck's Hardware or downhill, downtown, you walk uphill and then you're level on a street, and you walk uphill and you're level on a street? Well, those are carved in a certain pattern, a distance apart by probably bulldozers and blasting. But then within the yards, in the houses themselves, like our yard, has a couple of lumps. And I wonder if those are either lava layers that wore away or former water beach lines from Lake Superior that sat there at that elevation for a while and dug away the bedrock, and then it, I don't know if it went higher and dug some more or went lower and dug some more. But I see those up in the Grand Portage Reservation lands. You can see in the woods terraces that aren't lava, they're carvings. And then down in Duluth. So I'm guessing they're here, but they're obscured by roads, our lawn, my shed. You know. Yeah. Yes?
Talking about the river gorge, what kind of rocks is it?
I think, so I've only walked along the upper ridgeline of Devil Track and looked down. And then I walked a little ways from the highway up Devil Track. But I haven't seen the rocks very much in the walls. But I think it's a giant fault zone, I think, that cracked through, just like Chuck's fault, cracked through the basalt lavas and gabbro intrusive rocks, and then the river found that its way to that crack and has just eroded and eroded and eroded and eroded. And I think that because when you're hiking, even on the ridge line, where you come across a drainage that comes in from the woods and goes over or down the embankment and down to Devil Track, the rock types are solid, then they're cracked, and then there's a creek, and then they're solid. And so I wonder if it's a whole series of faults that are just making the rock weak, and then if there's moving water draining through, it's going to keep wearing that down slowly. Same with the Judge Magny Park and the Devil's Kettle and things. It's right through lava. But there are fractures that you can see here and there. Yes?
What could be some potential explanations for why the rift that we have here is not active, and like why it's stopped versus like the ones you talked about in other places that are still active and still getting deeper?
Yeah, no idea.
Okay.
There's a few failed rifts that are known around the world, but there's really no idea why they stopped. Yeah. Or why others keep going.
But they know they're like permanently stopped, or could it?
Hold out to the table. You know, I think it's a lot like, is the weather changing? You know, yes, it is.
Cycles.
It's cycling, there's, you know, a lot of the plate tectonics, the idea that, okay, this continent, which is sticking up out of the ocean and out of the active rift zones on the middle of all the ocean floors, which is making lava, pushing it sideways, it cracks again, pushes more sideways, and you put pressure on the continents, and the ocean plates, the lavas tend to go down under the more higher continents, and where they do that, you tend to get the Appalachian Mountains, but that stopped. And the melting of the rocks and the volcanoes stopped, but it's an old weathered volcanic mountain range, Or you go to the west side of the US and you have the Cascade Range, and then you have the Rocky Mountains, and those are thought to be the Pacific Ocean plate going down and melting rock down there from friction and everything else, and making a whole line of new rock in the form of mountains and crumpling whole continents into a mountain shape. But if you can if you can date or estimate the ages of these rocks through chemistry, as a matter of fact, you can say, maybe not exactly, but you can say, well, this rock was here first, and this one is much younger and formed second. And if you can age date the billion-year-old rift rocks, not the cracks, but the basalt and so forth, that billion years is thought to be a fourth of the Earth's age. And nothing's happened in that since then to this craton, to this piece of the North American plate. So will it ever fire up again? Will another continent slide under and make something else happen? Probably, I suppose.
Or another 500-mile asteroid.
Yeah, when are they coming? You know? Exactly.
I'd like to suggest that we move to the afterglow.
Okay.
And there's lots of time for questions. And Al, I would like to thank you again for just an incredible. Thank you so very, very much.
Well, you're welcome. Thanks for the invite. Appreciate it. Oh yeah, so there are lots of rocks. These are rocks from the county. And these are cool rocks from elsewhere, like gold and copper and things like